In the second to the in this, I mean, two videos before now, we talked about the Vieta's formula Vieta's formula extension, right? Talking about symmetric polynomials, and afterwards we talked about Newton's sums for polynomials, where we can actually find the the sum of the powers of roots even without knowing those roots. So we're able to do that using Newton's sums for polynomials. Now, in this case, we want to talk about the Cardanos method for cubic equations. So if you have cubic equations, I mean, this is specific to cubic equations. So if you have a cubic equation and you're thinking of a method exclusive to that, you want to think the Cardanos method for doing that. So let's go ahead and explore what this is about. So Cardanos method is a classical algebraic technique for solving general cubic equations. It reduces any cubic ax cubed plus bx squared plus cx plus d equals 0 to a simpler depressed cubic, then solves it using a clever substitution that expresses the solution in radicals. So we get solutions in radicals. So the method works for all cubics, including those with three real roots. I mean, one equation would be that like that is x cubed minus 6x squared plus 11x minus 6 equals 0, which I have solved in the last video and the one before. I mean, I made use of them because you know the roots to be 1, 2, and 3. So they are pretty easy to. So whenever we do anything with them, it's easy for us to check to see if our solutions are correct. So that's why I really like using that particular one. Okay. So what I've done here is to make this one stand out. So this method works for all cubics, including those with three real roots. That is casus irreducibilis. That is, you know all the roots. Though that special case requires additional trigonometric handling. Okay. Now, so step one now, in step one here, we normalize the polynomial. So you start with ax cubed plus bx squared plus ax plus d equals 0. And you divide by a, assuming that a is not equal to 0. Of course, if a is 0, it's no longer cubic. So divide through by a. So you can have x cubed plus ax squared plus bx plus c equals 0. That means that because you have divided through by a now, so b over a now is equal to a. So b over a is big A. B C over A is now big B, and D over A is now big C. And that's why we have x cubed plus ax, big AX squared plus big BX plus big C equals 0. Okay. Now, the next step after normalizing, so normalizing is dividing through by the leading coefficient. The leading coefficient is the coefficient of the x with the biggest exponent. Okay. So step 2 is to depress the cubic. So to depress the cubic simply means that you use the Chinos substitution, which is x equals y minus a over 3. So you see what you are left with now. You now substitute for x, you put y minus a over 3. Okay, this one right here. So this removes the quadratic term. After substitution, you get a depressed cubic. Okay, I think I want to do that so that we can be together. So we have we have normalized to x cubed plus big ax squared plus big bx plus c equals 0. And then want to substitute x equals y minus a over 3. Okay. So let's go for that. So don't forget we started with p of, okay, it's an equation, right? Started with a x cubed plus bx squared plus cx plus d equals 0. Okay. And then the first step we do is to normalize. So to normalize means to divide through by a. So we have ax cubed over a plus bx squared over a plus cx over a plus d over a equals 0 over a. Okay. So this cancels this. So we have x cubed plus b over a x squared plus c over ax plus d over a equals 0. So we now say this is x cubed plus b over a. Now we call that a. Okay. So because b over a now becomes big A x squared plus big B, which is now c over a x plus big C equals 0. So big C is d over a. So now this is what we have. So with that in place now, Then we then say, um, we then go for, we now say, we substitute the what it has this big name, Shinos substitution. The Shin Hos, I don't know if I should call it Shinos or something. Shinos substitution, which is x equals y minus a over 3. And then this removes the quadratic term. So that's the depression that is taking place. So we are depressing the cubic by removing the quadratic term. And when to do that, we substitute x for y minus a over 3. Okay. So substitute, we can say put x equals y minus big A over 3. Okay, so that means that we have y minus a over 3 raised to power 3. Okay, plus a into y minus a over 3 squared plus b into y minus a over 3 plus c equals 0. So this is what we have to deal with now. I mean, to expand this, we already know how some of these things work. So to expand this, we know this is y raised to power 3. So we can use Taylor's, what is that thing now? Pascal's triangle. Okay, so the first one, we have 1 times y raised to power 3, then minus a over 3 raised to power 0. Then we have 3 times y raised to power 2 minus a over 3 raised to power 1 plus 3 into y raised to power 1 into minus a over 3 raised to power 2. You see, the power of this one is increasing while the power of the second one is decreasing. So, I mean, the power of the first one. So this is 3 for y now, 3, 2, 1. And then lastly, this is 2 now, plus 1 into y raised to power 0 minus a over 3 raised to power 3. So this whole thing now is what we have done here. So, if I we can let's do it. Let's focus on it that way. So, if you tidy this whole thing up now, so this is y minus a over 3 raised to power 3 all the way here. So this is gone. So we have y raised to power 3. Then here we have 3 cancels 3, right? So we have minus a y squared. I think that's what we're gonna have there. Then here, okay, this is a over 3 again. So we have 3 cancels one of this. Okay. 3 cancels one of this. So we still have okay. I think I better be careful so that I don't have a problem there. So we have, I mean, this is fine. We have plus 3y into minus a squared over 9. Okay. Minus a squared over 9. I think that's what we have there. Then this is everything goes here. So we have minus a raised to power 3 over 27. Okay. So this is fine here. So this is y raised to power 3 minus ay squared. Then 3 here is 1, 3 here is 3. Then minus 1 over 3 a squared y. And then minus 1 over 27 a cube. I think that works. I hope I've not made a mistake. This is 1 y raised to power 3, yes. This is gone. Then here 3 y squared. Then a over 3. Yeah, 3 cancels out. Then here we have, yeah, this should be positive. This is positive. And we square all of that out. This is positive, yeah. So that alternating. So it's very important to be careful. So 3y into a squared over 9. 3 cancels 3. That's that. So we have, yeah, so we have that. 1 over 3 a squared y minus, yeah, here, minus 1 over 27 a cube. So we have that. Then the next thing is a into y minus a over 2 squared. So a into y minus a over 2 all squared, right? A over 3 rather. A over 3 all squared. So now this is the same thing as a into, so when we, I mean, this is easy peasy. So we have y squared minus 2y a over 3 plus a over 3 all squared. Okay. So that's a into y squared minus 2 over 3 ay. okay, plus 1 over 3, 1 over 9, okay, minus 1 over 9, a squared, like that. I think that makes sense. Y squared minus 2 over 3 ay. Yeah, plus that. So that means we have ay squared, okay, minus 2 over 3 a squared y, okay, plus 1 over 9 a cube. I think that settles it. Okay, we have this now. So we need this. We need this too. But that's not all. We still have another term there. We have by minus a over 3. So we have b into y minus a over 3. This one is linear, so no problems. So we have by minus ab minus 1 over 3 ab, like that. By minus 1 over 3 ab. So we have that. Then plus c. So we now need to put everything together, right? So putting everything together, So carefully, we have for the whole expression now. So we have y cube minus ay squared, y cube minus ay squared. Okay, y cube minus ay squared plus 1 over 3 a squared y. Okay, plus 1 over 3 a squared y plus 1 over 3 a squared y minus 1 over 27 a cube minus 1 over 27 a cube. Okay, that goes. Then next we have another, we have plus ay squared. Okay, I'm seeing some good signs. Plus ay squared. I'm seeing things canceling out. Okay, maybe I should even use another marker. Plus ay squared, which is this, minus 2 over 3 minus 2 over 3 a squared y. Okay, minus 2 over 3 a squared y plus 1 over 9 plus 1 over 9 a cube plus 1 over 9 a cube. Then here now we have plus by minus 1 over 3 ab plus by minus 1 over 3 1 over 3 ab. Okay, that's from here now. And then we don't forget the c plus c now equals 0. Okay, so now I'm seeing good signs here. I see this canceling this out because they are the same with opposite signs. Then I have 1 over 3 here, and I have minus 2 over 3 here. So we can begin to tidy things up. So we have y cube, then 1 over 3 minus 1 over 3. So that'll be minus 1 over 3 a squared y. Then minus 1 over 27 plus 1 over 9. So that's like 3 over 27. So that's plus 2 over 27 a cube, like that. Then plus by. Okay, this one now plus by minus 1 over 3 ab plus c equals 0. Yeah, to make, okay, let's see what we have on that note. I mean, it's been done here. Okay, it's now like y cube plus py plus q equals 0. Okay, with p being all of these things. Okay, I see that. Okay. Okay, so that requires some careful handling. Um, okay, let me see. I think I have to use these substitutions now. So I can just walk towards it. So if we tidy this up now, we use say p. P is b minus a squared over 3, and q is 2 over 27 a cube minus ab over 3 plus c. Okay, I'm beginning to suspect I have a, oh, okay, I think we are good. Oh, lovely. Okay. Okay, I think I'm still borrowing a leaf from here a lot. The final thing is y cube plus py plus q equals 0. Okay, So let's go for that and tidy it up that way. So here now we have y cube, okay, y cube plus plus y cube plus. Now let's study things up in terms of y now. We don't have y squared anymore because that's the essence. We want to depress the cubic expression. So y cube, then for, look at this now. For this and this now, we have y terms here. So this will now be like b minus b minus 1 over 3 a squared y, right? So they have y in common. So we have b minus 1 over 3a squared y. Then the next one now, we have things that don't have y, all the constants. Then plus 2 over 27 a raised to power 3 minus 1 over 3 ab plus c equals 0. Okay, so on the other on the worksheet now, remember what we have. This is now y cube plus py, because now p, this is the whole of this is p, so plus py plus q equals 0. So the whole of q now is this, plus q equals 0. So now we have depressed the cubic expression because we have taken away the quadratic part now. So one term is missing. That's what we mean by depression. Okay, so now back here. So using the substitution now, imagine we now ended up getting y cube plus py plus q equals 0, where p is b minus a squared over 3. That's, 1 over 3 a squared if you like. Q is 2a cube over 27. That's 2 over 27 a cube minus 1 over 3ab, which is ab over 3 also, plus c. So with that done, then we now go for the Cardanos substitution. Okay. So for the Cardano substitution, now we now say that we assume a form y equals u plus v. So y now equals u plus v. So if you substitute y equals u plus v into y cube plus py plus q equals 0, we get this expression. Okay. So we have u plus v cube plus p into, y is u plus v. So u plus v cube plus p into u plus v plus q equals 0. If you expand that, we have again, we do the whole expansion thing. We have u cube plus v cube plus 3uv plus p into u plus v plus q equals 0. A lot of steps have been jumped to actually arrive at this. Should I go for that right now? Should I go for that? Okay, let me go for it. We want to just substitute y equals u plus v in this simplified expression. Okay. So if y is equal to u plus v, okay, so y cube plus py plus q equals 0 will be something like u plus v raised to power 3 plus p into u plus v plus q equals 0. So we have, of course, Pascal's triangle again. So you have u cube, okay, plus 3u squared v plus 3uv squared plus v cube. That is easy because there's no fraction. Then plus p into u plus v plus q equals 0. Okay. So here now we see that this is u cube plus v cube. If we put these two together, and from here we have uv is common. Rather 3uv is common into u plus v, like that. See, uv is common, uv is common. So if uv goes here, we have u left, we have v left here, plus p into u plus v plus q equals 0. Okay, so that we now have u cube plus v cube plus u plus v is common to this, so you have u plus v. Okay, let me be careful with that. So you have u plus v being common into 3uv plus p, then plus this q now equals 0. I think we have that much over there. So that is u cube plus v cube plus 3uv plus p. That's what we have, right? A 3uv plus p into u plus v plus q equals 0. So we now want to eliminate the u plus v. Now to eliminate u plus v, we have to impose that 3uv plus p is equal to 0. Okay, so if this is 0 now, automatically Um, so if we take this to be 0, we are saying that uv itself has to be minus p over 3, right? So this term will be gone, and then the equation reduces to u cube plus v cube plus q equals 0. But don't forget we already have uv to be minus p over 3. Okay, so we can then let big U be equal to U cube, and big V is equal to V cube. Then we can now say that U plus V is equal to minus Q. Big U plus big V is equal to minus Q. And then UV will now be UV cube minus, and UV cube, you remember, UV cube will be minus P cube over 27. So thus, U and V satisfy the quadratic. So this U and V now will satisfy the quadratic that T squared plus QT minus P cubed over 27 is equal to 0. Okay. That's because we have taken big U plus big V to be minus Q now. Okay. And we know that the big U plus big V is equal to, small U plus V is Y. So finally, this whole thing satisfies this expression, T squared plus QT minus P cubed over 27. Now this is a bit mm, it's somehow, right? But that's what we have going on here right now. Okay, so in step 4 now, since this is a quadratic expression, we can easily solve quadratic expression. So step 4, we solve for u cube and v cube. And how do we do that? This now. So if we solve t here now, then we are basically solving for all that. So solve for u cube and v cube. So we basically have this quadratic expression, and then we just solve for t. So to solve for t being a quadratic expression like we have already, so we have a is 1, b is q, right? And then c is minus p cube over 27. So if you solve that, we have t squared. To solve t squared plus qt minus p cube over 27 equals 0. Then t is equal to minus b, that's b is q. So minus q plus or minus square root of q squared plus 4. That's 4 times 1 times 4 times AC, that's 4 times 1 times minus p cube over 27. That's what we have right here. All over 2 times 1, which is 2. Then if you define the discriminant, now you see the discriminant is q squared over 2 plus p over 3 all raised to power 3, right? So here now, if you look at this, it's more like you take out, so q over 2. This 4 here, you can bring it on down. It will be like divided by 1 over 4. So that way you have q over 2 squared plus p over 3 raised to power 3. Then that means you have u raised to power 3. U raised to power 3 now will just be minus q over 2. So u raised to power 3 is minus q over 2 plus the determinant, plus the discriminant, and v cube is minus q over 2 minus the discriminant. So this is u cube, this is v cube. Thus, y equals u plus v will now be the cube root, y, which is equal to u plus v now, is the cube root of u cube plus 3 plus cube root of minus q over 2. This is u cube now plus v cube right here. So the cube root of each now, because cube root of u is u plus cube root of v is also v. So finally, we now say that x is equal to y minus a over 3. That was the substitution we made the other time. So we have to take it back to that, because now we have finally got y, and then we take it back to where we are coming from. Okay, step 5 now is such that you interpret the discriminant. So you have the discriminant is q over 2 squared plus p over 3 cube. So when the discriminant is greater than 0, you have 1 real root and 2 complex roots. So in this case, it's not like the regular one we know. So normally when discriminant is greater than 0, for quadratic expressions, you have 2 real roots. But here, if it's greater than 0, you have 1 real root and 2 complex roots. If discriminant is 0, you have all real roots, at least 2 are equal. Then when the discriminant is less than 0, you have 3 distinct real roots. That is casus irreducibilis, especially if you have the kind of expression I've been solving. That's x cubed minus 6x squared plus 11x minus 6 equals 0. So let's look at some mock examples. Though this looks somewhat clumsy, but it's okay. It's just need to know this idea of Cardano. So example one, for the simple discriminant greater than zero, you have x cubed minus 6x plus 8 equals zero. So this is already depressed, so we don't have to depress it. And it is already normalized because the coefficient of x cubed is 1. So here now, we just have p to be minus 6 and q is 8, basically. So we compute q over 2 squared plus p over 3 cubed. That's the discriminant in this situation. So that will be q over 2 is 8 over 2, that's 4 squared. P over 3, that's minus 6 over 3, that's minus 2 cubed. So you have 16 minus 8, that's 8, which is greater than 0. And once it's greater than 0, what happens? It means you have one real root and two complex roots. Then you can compute u cubed now to be minus 4 plus root 8. So that's minus 4 plus 2 root 2, uh, plus 2 root 2, like that. Okay, I think, yeah, I need to separate this because they have been lumped together. Yeah. I think this is great now. Where is it now? Yeah. So this has been split up. So v cube is minus 4 minus 8, and that is equal to minus 4 minus 2 root 2. So thus, x now is the cube root of this plus the cube root of that. So that's where, so you can numerically check that this equals x equals 2. So this whole thing is like x equals 2. But it's more that's why we talk about it, that the answer is in terms of radicals. So when you have surds like this, you say it's in form of radicals, but you can actually find the numerical solution. I mean, you can definitely find the cube root of negative value too. So you can check numerically that this equals x equals 2. So with this now we have, so basically all you just need to do is to down to depress. But if there's no need to depress, then you just go straight. So for the case of casus irreducibilis, you have x cubed minus 3x plus 1 equals 0. So here the p is minus 3. This is also already depressed, right? So we don't have to worry about depressing. So x cubed minus 3x plus 1 is 0. So you have p minus 3 plus q equals 1, right? So the determinant is half, that's p over 2, I mean q over 2 squared, as usual, plus p over minus 3. That's minus 3 over minus 3, which is minus 1 cube. So if you do all that, you have minus 3 over 4 less than 0. That means once it's negative, you have three distinct roots. So if you now do trigonometric substitution now, so you say let x be equal to 2 roots. Okay, let's see. Hope I have not lumped many things together. Yeah, I think it's good. Yeah, everything is fine. Okay, so we have p is minus 3. So trigonometric substitution now. So let x be equal to 2 roots minus p over 3 cos theta equals, which is all 2 cos theta now. Then the equation becomes 2 cos 3 theta, which is minus 1, and cos 3 theta will now be minus 1 over 2 if you divide both sides by 2. So this expression now, so we are taking 2 root minus p over 3 cos theta to be equal to 2 cos theta, right? So that 2 cos 3 theta is now minus 1. So cos 3 theta is minus 1 over 2. So cos 3 theta can then be 2 pi over 3, 4 pi over 3, 6 pi over 3. So pi is now 2 pi over 9. Uh, Theta is 2 pi over 9, 4 pi over 9, 2 pi over 3, and so on. So then you have the roots to be x1, x2, x3. That's 2 cos 2 pi over 9, 2 cos 4 pi over 9, x3, 2 cos 2 pi over 3. Now, so I think I want to I have to take care of this now so we can actually uh, we can actually do what is right. So what I'm going to do is to, instead of just going ahead to compute this now, I'm going to depress this based on what we did before, and then I'll follow the steps we have up there and then depress. Okay, so we want to reduce x cubed plus 3x squared minus 4 equals 0 to a depressed cube, to a depressed cubic. Okay, so I'll carefully follow what we've done there. So the deal is to reduce x cubed plus 3x squared minus 4 equals 0 to a depressed to a depressed cubic. Okay. The question is, what did we do to depress it, right? So first of all, we have to follow that carefully. So to depress the cubic, what did we do? First thing, we had so we normalized. So in our case now, everything seems to have been normalized already, right? Everything is already normalized. Okay. So the way this is now, it is already normalized. So it looks like we already have this to be uh okay. So okay, let me just compare. So compare with x, compare x cubed plus 3x squared minus 4 equals 0 with the regular depressed form. I mean, the normalized form, that's x cubed plus a x squared plus b x plus c equals 0. So what this simply tells us, if I check that again, I have to tread carefully because that can be pretty clumsy. Okay, yeah, with what we have here, we have a, b, c, blah, blah, blah. Okay, yeah. So I come back here now. So everything looks good. Everything looks like that. So we can say that A is equal to 3. Capital A is 3. Then capital B is 0 because there's no term in X. And capital C is minus 4. So we have this in this case now. So, and then we know that to depress an equation, I mean, to depress the cubic, we need to substitute x equals y minus a over 3. Okay? Uh, so to depress the cubic, to depress, to depress the cubic, okay, we substitute y equals, sorry, is it y now? Yeah, x equals y minus a over 3. Okay? We substitute x equals y minus a over 3. Yeah, that's what we do. Thankfully here, this a is a number, so we can just use that. Okay? So here now we have, so this implies that x is equal to y minus, our a is already 3. Lovely. So we have 3 over 3. So x is equal to y minus 1. Okay, so we substitute x is equal to y minus 1. So we go for that. So from x cubed plus 3x squared minus 4 equals 0, we have, so when we see x, we put y minus 1. So we have y minus 1 raised to power 3 plus 3 into y minus 1 raised to power 2 minus 4 equals 0. Okay. So with this now, we then have y minus 1. So this is, we expand, we use Taylor's, what is that thing called now? Pascal's triangle. So this is y raised to power 3. Okay. Y raised to power 3. Okay, I mean, let me go carefully. Let me go carefully so I don't mess it up. So we have y raised to power 3 into minus 1 raised to power 0. So that's 1 here plus 3 y raised to power 2 minus 1 raised to power 1 plus 3 y raised to power 1 minus 1 raised to power 2. Okay, plus 1 into y raised to power 0 minus 1 raised to power 3. So 3, 2, 3, 2, 1, 0. Then 0, 1, 2, 3. Cool. Then the next one is easy. We have 3 into, just expand that. We have y squared minus 2y plus 1 minus 4 equals 0. Okay. So we then have, so here, this is 1. Sure. So this is y cubed. Then this is minus 3y squared because this is negative. And this is positive. So we have plus 3y. Then here it's negative. So that's simply minus 1 because 1, 1, right? That's my, so the minus has to be there. So minus one. I hope everything is fine. This is one. This is y cube. This is minus one. That's one. Okay, so this is plus, sorry. Sorry. This is it's negative. Minus one raised by one is negative, yeah. 3y squared. Then this is minus one raised by two, that's one. Times 3y, that's 3y. Then minus one. Yeah, that works. Then here we have 3y squared minus 6y, yeah, plus 3 minus 4 equals 0. Okay. So here, joyfully, the quadratic is gone. That's the depression happening right here now. So here we have y cube. We can tidy other things up. So y cube now. For 3y, we have plus 3y minus 6y. That's minus 3y easily. Then here, minus 3 plus 3, that's minus 2. Minus 4, that's minus 6. That's minus, sorry, minus 1 plus 3, that's 2. 2 minus 4 is minus 2. Yeah, that's minus 2. Okay, that is minus 2. Let's go again. Y cube, then 3 3y minus 6y, that's minus 3y, yes. Then minus 5 minus 4, minus 1 minus 4, minus 5 plus 3, that's minus 2. Yeah, I think that works now. Everything is fine. And this is equal to 0. So this is the depressed. So we can say, therefore, the depressed cubic is y cube minus 3y minus 2 equals 0. So now that it is depressed, then I believe we can then solve it. I think I want to go all the way and even solve it still. Let's look at, so using the worked examples now, without even bothering about all the trouble. Okay, now we have it well in the depressed form. So we just need to identify our P and Q. So as usual, P here is minus 6 and Q is 8. So I'll go for that. So I'll just follow this now. P is minus 6 and Q is 8. Okay. So here, P, so I say here, P is minus 3 and Q is minus 2. Okay. Q is minus 2. So if I want to go by that, then I can do all these other troubles. So we can compute the determinants. So Q over 2 squared plus P over 3 cube. Okay. Okay, let me go for that. I think I've forgotten. This is, yeah, Q comes first. Q over 2 squared, P over 3 cube. Okay. So the determinant is Q over 2 squared plus P over 3 cube. Okay. That's the determinant in this situation. And the numbers are looking great. So the numbers are looking nice. So the next thing is to fix those values and tidy things up. So I go for the determinant now. Q is minus 2, so minus 2 over 2 squared plus P minus 3 over 3 cube. So that means the determinant is minus 1 squared plus minus 1 raised by 3. So that means we have minus 1 squared is 1. Minus 1 raised by 3 is minus 1. So the determinant is 0. Okay, the determinant is 0. So when determinant is 0, what does that mean? Okay, for 0 determinant now, it means that all real roots, at least 2, are equal. Okay, so we can say that. Okay, since the determinant, is 0, all roots are real. Okay, and at least 2 are equal. Okay, so since if we can get the determinant, then we can as well get we can then get the roots. So let's go for the roots. But I mean, you see, I'm following all those things closely. So we then want to compute so we know x is u cube plus v cube. But um okay, so u cube now is where is this minus 4 coming from? Let me see. U cube is minus 4. Okay, u cube is minus q over 2 plus plus square root of determinant. Okay, minus q over 2. Okay, I think it's better to go carefully. You know, the substitution that would have been made before is that okay, I think I can take it up from here. So we recall from the substitution, right? Recall that x is equal to u plus v. You know, this is we are looking for x ultimately. But but so that means that x is equal to cube root of u plus cube root of v. Okay, cube root of u plus cube root of v. And then we should know that u itself is this is now cube root of so for u alone, I mean this takes a lot of carefulness. For u alone, we have minus p, so that's minus p over 2. I mean minus q over 2. Yeah, minus q over 2 plus square root of determinant. Okay. This is minus q over 2 plus square root of the determinant. Thankfully, our determinant is 0 in this case, so we are good. Then here, that'll be cube roots of minus q over 2. This is plus, this is minus, minus square root of the determinant again. So with this, we can get our x. So x now is cube root of, now, minus q. Q is again, Q is minus 2, thankfully. So Q is minus 2. So we have uh minus 2 over 2 plus square root of 0 plus cube root of minus 2 over 2 minus square root of the determinant. Okay. So here now we have x to be we have x to be um cube root of minus 1 plus cube root of minus 1 again. Because of course this will go, all these zeros are gone. And we know all the roots, we have at least 2 equal roots and things like that. So here we have cube root of 1 plus cube root of 1. So that cube root, not square root, cube root. So x is equal to 1 plus 1. Cube root of 1 is 1. So x is equal to 1. Okay? So obviously one looks like should be one of the solutions. We can test, we can check. So we check now and see. So we have x cubed plus 3x squared minus 4. So obviously 1 is one of the roots. So we have 1 cubed plus 3 into 1 squared minus 4. So that is 1 plus 3 minus 4, which is 0. Yeah. So x is a root. So that's correct. Yeah. Yeah. So 1 is one of the roots. So it means that at least 2 of the roots are 1. But we can confirm this using a plot. I mean, this is really clumsy, but I hope of course I think that there are better ways of handling this, but I think it's just good that we are introduced to this concept. X cubed minus 3x squared minus 4. Okay, in fact, the only real root is 1. Is okay, it's even 3.3553. Then how come we got 1? Ah, this is serious. Okay, so that's what we have. So that's what I see right there. So I don't know if something is wrong or not. But I mean, I can as well just stop here because Cardanos method is somewhat clumsy, but you can follow it through. If you really need it, you can sit with it and see how it turns out. Okay. So thank you so much for listening. This has been such an exciting challenge, by the way. All right. So let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I must thank you very much for doing that. If you haven't, what are you waiting for? Why not just go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also go ahead and join, become a member of this channel by clicking on join. And you have three levels of membership. They're the highest level. If you are a member at the highest level, we can meet face to face if you're in the same geographical location at any point in time, or we can hang out online to talk about anything that interests you on my channel, be it mathematics, data analysis, data science, machine learning, um, whatever, scholarships, writing books, personal development, anything like that. Okay? Till I come your way again, keep doing maths right. Oh, well, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.